So the first one we were asked which one was a metal. So I'm actually going to change my paper that I have out because these were the hints that I gave to everyone yesterday after your class, all right? And that was that we look on the periodic table for that stair step case, right? The staircase. And when we find that staircase, we know that nonmetals are on the right, metals are on the left. So we wanted something that was to the left on the periodic table. So looking here, we have lithium, silicon, and sulfur. So it would be lithium, the one furthest to the left. Okay? All right, the second one was smallest ionization energy. So we were thinking the ice cream cone trend, okay? And from that, we have to figure out if we're going side to side or up and down. So we have sulfur, phosphorus, and, nitrogen, phosphorus, and arsenic. Nitrogen, phosphorus, arsenic. So we have an up and down. So we're thinking of our ice cream cone regular direction, right? So we're thinking this one right here. So we want to know who has the smallest, who was at the bottom of that little group, and that would have been arsenic. Okay? All right, the next one we have is largest atomic mass. This has nothing to do with our trends. It has to do with our periodic table. So you would just look up who is the biggest here. Most likely it goes with the radius, but you should just be checking their mass, which is down here. So we have 39, we have 40, and we have 44. So who is the biggest out of those three? 44, right? Yeah, so scandium. So we're going to go ahead and circle scandium. All right, member of the halogen family. So I gave you the reminder, your halogens are in group 17. Remember, groups are the vertical families, right? So group 17. And we need to find one of these in that group. So we have sulfur, chlorine, argon. Who is that? Which one is in group 17? Chlorine is. Good. All right. Here we have electronegativity, and I want the greatest electronegativity. So we want the bigger end of our ice cream cone, right? So we have aluminum, silicon, and phosphorus. So aluminum, silicon, phosphorus. So that means the sideways little ice cream cone, right? So who's at the far end? That would be phosphorus. The next one was largest atomic radius. So we're thinking snowman trend, right? So snowman trend, we have gallium, aluminum, and silicon. So gallium, aluminum, and silicon. So we have kind of like an L shape here. So it's not as obvious as just picking two of them, right? Like we were doing yesterday. We have three things to consider. So this is the way to handle that. You want to pick the one that is lowest. That rule will always trump the going across rule. Okay? What I mean by trumps it maxes out, like it's more important. So we're looking at the aluminum versus gallium. Who is the bigger of the two? That would be gallium, and that's your answer here. It's also the one that's furthest to the left corner. Bottom corner, all right? So, again, we look at this whole idea. It would have been aluminum. Then you look between aluminum and gallium. It would be gallium, okay? So your answer for that one would be gallium, and it was combining both the snowmen, sideways and up and down, but up and down is more important. All right, largest atomic number. So you're just looking at your periodic table, so you should have found vanadium, niobium, there you go, and whatever TA is. I don't have that one memorized. My bad. So, which one has the biggest atomic number? Remember, atomic numbers are the ones that are on top. TA. Where's that one at?
73.
73. Perfect. There you go. Oh, tantalum. Got it. Cool. All right. Member of noble gases. So we're looking for someone who is a part of group 18, the furthest to the right on your periodic table, right? Group 18. Which of those three is in group 18? Xenon. All right, your 4 energy levels. That means the fourth period, the fourth row on your periodic table, right? So we have silicon, germanium, and tin. So silicon, germanium, tin. So we're here. We want to know the one that is in the fourth row. That would be germanium. Okay? Member of your alkali metals. Alkali metals are all in group 1, the first family on the periodic table. You got to know that name, by the way. You'll see that one. All right, so group 1, who is in group 1? Who is it? You're okay. You're not the only one. It is lithium, okay? So again, we're just looking for who is in group 1. All right. The next one said 6 valence electrons. So I went ahead and told you what group that's found in, but I want to make sure you know how to figure out your valence electrons. So remember, your valence electrons, you can refer to this little spot on your periodic tables, and that is the one that has the 1A, 2A. Remember, transition metals, we don't talk about that. We stick with our main group elements, so 3A, 4A, 5A, 6A, 7A. Those are going to be your valence electrons. So if I want one with 6, that means I was looking in group 16, okay? Your 6 valence electrons. So tomorrow, something that you will see is something called a Lewis dot diagram. It's really simple, which is why I didn't really cover it too in depth. So you'll be able to figure it out as long as you know what your valence electrons are, okay? Because I'm not getting you on where the dots go right now. That's next chapter. But you should be able to tell me how many valence electrons something has. All right, so which of those 3 is in group 16? Arsenic, selenium, or bromine? Selenium. All right, who is a nonmetal? Who is on the right hand or right portion of the stair step? You should be saying none of the above, right? None of them are on the right. Okay, so let's take this one step further. We have lithium and sodium. Those have been metals that we've been using in the past. What do we know about hydrogen? Is that ever a metal? No, hydrogen is a gas. You guys have heard of hydrogen gas. We got to see a little bit about hydrogen gas, I believe, on Halloween, possibly. We're gonna see hydrogen a lot, but that's when you get bubbles. So when you guys had dropped the iron into the acid for the lab, the bubbles, the stinky bubbles, those were hydrogen. Okay. All right. So hydrogen is the answer for that one. So that was a kind of a tricky one because it's not necessarily the staircase thing. You had to know it. All right, member of transition metals. So transition metals is the D sublevel. That means the center part. D sublevel, center part. So which one is part of the transition metals? Hg, mercury. Electron distribution of S2P1. So remember, we focus on the last thing listed, P1. So that means that we're looking in the P sublevel, first thing listed. So we are looking in group 13. Group 13. So aluminum is correct. All right, a metalloid is everything that's touching the little stair step case. So when you looked at lead, bismuth, and polonium, what is the only one that's actually touching the staircase? Polonium. Okay, meaning it was like right here. Okay. All right, gas at room temperature. So this one, I'm probably not going to test you over, but just so you know where you can look for that is on the big periodic tables. Those are all color coded. All right, and so anything that's in black means that it's solid. Red means it's a gas, and blue means it's liquid. So these, you had boron, carbon, and nitrogen. And so if you look up there, because you would think carbon, you're like, that's gas. No, that one's actually like coal or charcoal. Like if you're grilling something, that's carbon. Okay, boron, that's a metal or metalloid. And then we have nitrogen. Nitrogen was the only nonmetal, which was a gas at room temperature. So it's the only one that's in red on the periodic table back there. All right. So again, I'm not going to test you over that one. All right. Electron distribution of S2D2. So we wanted to look in the D sublevel, second one over. We were looking in group 4. Group 4. So who is in group 4? TI. That is correct. Yep. All right. So those were the answers for this first page.